Good morning, everybody, and welcome back to Nextdoor NetAdmin. Today we're going to talk about file systems. This is in response to a comment left by Trank Vista saying, can you talk a little bit about various file systems? File systems including NTFS, ZFS, XFS, ext4, and talk a little bit about the choice as pertains to what's good for archiving data or what's good for everyday accessing data. So let's dive into file systems in general, because I know I've talked a little bit about ZFS in the past, but where does that fit into the entire spectrum of file systems? So first off, what is a file system? Let's just start there. Conceptually, we all understand, most of us, what a file is on a computer. It is a section of data that typically represents an object of some sort. It might represent a text file, it might represent a Word document, maybe it represents a spreadsheet or a video or a picture or a piece of music, something like that. It is data, zeros and ones, that is conceptually regarded as a single object. Cool. Where are you going to put those? If you're just thinking on the terms of files, you go, well, I put files in folders, and I put folders in a filing drawer. Okay, we see folders, they're a part of their file systems, but the filing drawer is where we get to filings, is where we get to file systems as it is. Now, if I want to really extend this analogy and make it more tenuous, there's different types of filing drawers that you can use. Maybe you want just a manual drawer, doesn't really slide all that much, but you just pull it out, you slap a folder in, you kind of brush it up to try and keep it standing up straight, and then you push it back in, okay? Maybe you have something that is a big metal unit with big multiple rolling drawers, and it's got those nice little railings where you can have hanging files. That would be cool. Maybe you have something in between, one of those smaller metal units that has two drawers, top and bottom, and it's got maybe some dividers so that you can kind of sort out where those folders are. Your different file systems are like your different types of filing drawers or filing cabinets in this case. They all have much the same purpose. They're there to let you store your files. And yet they're all slightly different in how they go about doing that. Which one you choose might be down to personal preference, but there might also be some features that make one system better for certain purposes than a different system. Originally, a file system, and I'm going to use FAT in particular as the example here, that just stands for File Allocation Table. The file system, as it is basically an index. You keep an index, you say this file is in this block, this block, this block, and this block. Next file is in this block, this block, this block, this block. And as you update it, it might need to move to different blocks on disk, something we call fragmentation. And your index entry has to be kept updated to figure out what blocks on the disk are already allocated to files and what blocks are free. And so that is a very simple example of one of your most basic file systems, FAT, File Allocation Table. For various reasons, this kind of a system is vulnerable to a lot of corruption if the power goes out while you're writing something to the disk. How does the when the power comes back on, how do you know where you left off? Worse, if you have a corrupted file, maybe you can recover from that. Maybe you just say, oh, there's a whole bunch of garbled section in my Word document. Maybe I can just erase that and rewrite that section of the document. Okay, not the end of the world. What happens, though, if the section that was being written was the file allocation table itself? Now your disk doesn't properly know which sections of your disk are in use or are free. You might end up losing some free space, as it says, this section is allocated. To what? I have no idea, but I say that it's allocated. Okay, now you've lost some of your disk space. Worse, what happens if it says, oh, this is actually supposed to be free, and it stores something else there and overwrites a section of possibly a critical file like a Windows system file? This is not great. So you will often have some tools to catch and repair issues like this, but the damage that it can do can be substantial. This is why you don't typically see FAT used for a main file system, at least not since Windows Millennium, give or take. The next class of file systems, which is basically all the standard file systems today, outside of a few special purpose file systems for like flash drives that we're not going to get into a whole lot. The standard file systems these days are all of a type called journaled file systems. This includes a journal. The journal keeps track of all the things that you want to write to the disk before you actually start writing to the disk. You might say, that sounds really inefficient. You're essentially writing the changes twice, once to the journal file and then once to your regular storage. Yes, that is what you're doing. But the benefit there is, if you crash the journal, you haven't made any changes to what's on the disk yet. It is still consistent, and that is the goal that we're looking for. You probably lost, if your journal crashes, then you've probably lost whatever it was you were intending to write in the first place. But you haven't actually made any of those changes on disk. You haven't started those changes, and you haven't left something uncleanly in progress. If you write the journal successfully, and then you crash while you're committing those changes to the disk, then you can go back. When the system comes back up, you say, oh, looks like I was in the middle of writing something. Let me go back to the journal and backtrack all of those changes. Where did I get to? Now I can write out the rest of those changes, and the system will be consistent again at the end of it. That is the goal. A lot of these journaled file systems are the file systems that you see around you today. NTFS in the Windows era, that stands for New Technology File System, because at one point Windows NT was new technology back in the late 90s. That was with NT 3.51 and then NT4, which led into Windows 2000. And then once you had Windows 2000 was the NT line. Windows Millennium Edition was the older Windows 9X code base. They merged together, and you still have the NT kernel and the NT file system in use today. They merged with Windows XP. They continued off, and that's still what we're working with today. NTFS has had a lot of additional changes and features added to it through the years, and I'll come back to those in a minute. On the Linux side, one of the most common file systems you'll see is ext. Actually, this received a second version, ext2, which, similar to FAT, did not have a journal. ext3 is the same ext2 file system, but with a journal added. And then ext4 is the same ext2 file system with a journal for ext3, and it also allocates disk space based on extents, which is an entire group of blocks rather than block by block. This is an efficiency thing. If you allocate by extents, then you have less fragmentation because more of those blocks are being written in a single contiguous group. That helps speed the system up, makes it more efficient. Cool. EXT, however, if you had something like a journal crash that you somehow could not recover from, because it's the same thing as ext2, you can tell the system, forget about the journal, pretend this is an ext2 file system, and it will still work because it's just ignoring the journal. You can recreate the journal, you can clear it all up, and then later you can try remounting it as ext3, and it'll begin using the journal again, or ext4, and it will start working with extents again. So that gives you a little bit of flexibility there. Other file systems, Apple's HFS Plus, Hierarchical File System Plus, because it's newer than the original HFS. Also a journaled file system, same idea. XFS, the X was going to be replaced with something else, and Silicon Graphics never got around to actually filling in the X, so it's just XFS. Okay. Also a journaled file system. All of these are journaled file systems. Not ZFS. We'll come to that in a minute. But these are the standard file systems that you see around you today. Now, the journal may or may not cover all the data that you're trying to write. The journal will cover your metadata, the important things. What blocks are being used by this file? What's the time and date stamp on this thing? How big is it? If there's a checksum, what's the checksum? Who owns the file? What permissions are associated with it? All of the data that is about the file without being the actual file data itself, or what we would term the user data. User data may or may not be journaled. That depends. Regular NTFS does not journal the user data. It only journals the metadata. Again, remember, the goal here isn't to save the data, because if your system crashes while the journal is being written, you don't have it anyway. The goal is to make sure that you have a consistent file system so that when the system resumes running, it's not suddenly missing a bunch of files, or worse, accidentally overwriting the files it needs to actually run. So NTFS does not journal user data. If something happens, it's pretty much gone, but at least you'll have a consistent file system so that Windows itself is not affected. That's the goal, not a guarantee. It's a goal. NTFS also had a variant called transactional NTFS, where all of the data, metadata and user data, was bundled into a single transaction in the journal, and then either you would commit the whole thing as a block or not at all. Period. Transactional NTFS has been deprecated, and using it required quite a few hoops to jump through, so it's no longer a thing. We still have regular NTFS. It journals your metadata. It does not journal user data. That's the way it is. EXT, you can choose either way. You can choose to journal user data, or you can choose to journal only metadata. The choice is up to the administrator. So some of these can be tweaked or tuned a little bit, but there's no assumption that it's going to verify that data. And it doesn't cover what happens once it's been written out. If it's been written out and the hard disk makes an oopsie as it's reading it back in, it meant to read a 0 and there was a little electrical glitch and it read a 1 instead. Stuff like that happens. How do you know that what you're retrieving from the disk is actually what was written in the first place? How do you know that everything is the way it is and it did just get corrupted on disk or get corrupted in memory? That's where you get to the next generation of file systems, which I would typically, mostly I refer to them as next generation file systems or advanced file systems. However you want to call it, the next generation of file systems tends to include features that can verify that the data you are saving and retrieving is the data that was intended in the first place. So ZFS has a checksum attached to every block of data, and the checksum of one block is stored with the parent block, so that when you look at the entire file system as a tree starting from the very top and then branches out into various folders and then various files under that, it forms something which is referred to as a Merkle tree. No, you don't have to remember what that is. You don't even have to know what that is. There will not be a test. There are other file systems that do similar things. There's several based on B trees. Bitterfis, BTRFS, depends on what it means. Technically, you could say it's B-tree file system, BTRFS. Some people say it stands for better file system. Some people say it stands for butter file system, as in using it is as smooth as butter. Bitterfis is one of the newer, not brand new, newer file systems. It's not fully stabilized yet. Similar to ZFS, you can arrange your disks in a variety of topologies, whether that's RAID 0, not safe, RAID 1, standard mirroring, although the way that B-tree file system does it is very different from how ZFS does it or how a RAID controller would do it. It also offers some support for RAID 5 or RAID 6 topologies, but they're marked not stable. They're not ready for production use. And in some cases, under certain circumstances, if you have a power outage, your entire array may go bye. It may become corrupted, and there's nothing that can be done about that. It's not stable. It's not ready yet for those topologies. Other topologies, it may work fine. Another option for a file system is Bcache file system, Bcache-FS. It's based on a B-tree caching program called Bcache. Imagine that, creativity. And similar to B-tree file system, there's some things that it is ready to do. There's some things it's not ready to do. All of these are using checksums. There's a next-gen file system for Windows, too. It's called REFS, which stands for Resilient File System. Similar to all of the other next-gen file systems I've mentioned, it uses, basically, copy on write, although Microsoft had to be different, so they called it allocate on write. It works the same way. I don't know why they had to call it something different. And by default, it also only journals metadata. Does not necessarily protect user data, but it can. It has that capability. But there's some other gotchas to using it, and it's kind of its own beast. It's very much meant for a specific application, and in my view, yeah, you could use it. You probably wouldn't lose data to it, but it might not be all that convenient compared to your standard NTFS, because there's a lot of things like booting a system. For the longest time, you can only boot from NTFS because that's all the bootloader understands. Hand it this new REFS, it has no idea what to do with it. Okay, so there are some gotchas there, but you can start to see how there are a lot of options for administrators to pick and choose from. So, how do you distinguish between them? Which ones are good for archiving data versus everyday access of data? I would go so far as to say that the everyday standard file systems you see are perfectly good for your everyday accessing data. That's kind of their bread and butter. That's what they do day in and day out. NTFS, nobody's going to have an issue with NTFS on the Windows side. It's your workhorse. It's what's there. On the Linux side, ext4. Cool. That's the latest version of the extended file system, ext, and it does the job. It does it perfectly well. If you're using something like XFS, because that's one of the ones that Trank Vista asked about directly, XFS is optimized for a high number of disk operations. And specifically when you've got a large number of threads accessing the disk at the same time. In everyday use, I would probably go for ext4. Because in everyday use, I'm not doing a lot of disk access all the time. And I certainly don't have multiple CPUs with multiple threads all independently accessing the disk. In most operating systems, those will get passed to a disk access thread, which will queue up and, manage the disk, rather than multiple processes directly accessing the disk. So for a normal everyday user, I wouldn't necessarily see the point of something like XFS. And ext4, based as it is on the ext2 and 3 file systems, ext4 support is probably a little more widespread than XFS. It's just, I know where I can get an ext4 driver for Windows if I really need to. XFS, I'd have to do a little more searching. But Archival's a different thing. If I'm putting something into Archival, I want to really make sure that when I come back to this thing in 6 months, a year, 2 years, 4 years, however many years down the road, I want to make sure that what I get back from those disks is what I put there in the first place. So in that case, I might choose something that is deliberately designed to verify the data that was put on there is what I'm getting back. That might be something like ZFS. Happens to be what I know. I'm going to, select that for that purpose. It might be something like REFS on the Windows side. There might be other options as well. It really comes down to what are the features that you're looking for and what is sensible for that use case. ZFS has the capability to add additional features like additional read cache, additional write cache, deduplication, all of these things that can make it more performant if you're using it in something like a SAN or a NAS or something like that. Would I necessarily use that on my desktop? Probably not. I don't really see a point to all of that on a single desktop. Infrastructure, yes, I totally see the point of that. That makes sense. NTFS, I'd use that pretty much anywhere. ext4, I'd pretty much use that anywhere. I feel like I lost my train of thought there. Regardless, if I needed to use something like a Synology, last I checked, this may be different now, but last I checked, Synology offered 2 types of file systems, ext4 or BTRFS. I might go with ext4 just because I know what it is and I know how it works. B-tree file system, I also know what it is and I also know how it works. And I know that putting it in a RAID 5 or RAID 6 equivalent configuration is not safe for the data. And they explicitly say it's not safe for the data. Synology offers it. You can use it that way if you choose. But admin beware, it's not production ready. The code says so. So, yeah, I mean, but on the other hand, if I was going to use something like RAID 10, RAID 1, and then stripe across those mirrors, maybe B-tree file system is okay, because RAID 1 is stable, even if it works differently from a standard RAID 1, and striping, that's just to increase performance. So yeah, it all comes down to doing your research. Seriously, doing your research, looking at what features a file system offers, and figuring out what works best for your particular use case, whether it's archival or whether it's just everyday file usage. So hopefully that has been illuminating for you, and I hope that it answered your question, Tranquista. If you have any thoughts, my dear viewers, on stuff that you would like me to talk about, stuff you've kind of wondered, or stuff that just needs a bit more of an explanation, feel free to let me know what you'd like me to talk about right down there in the comments section. Otherwise, thank you very much for watching. I am your next door netadmin, and we will see you next time.